Thank you so much for being here. This has been a fantastic conference. It's an honor to be here. First time in Spain, actually, so I'm loving it. I got to walk around downtown towards the beach and everything back on Tuesday, and it was awesome. Very muggy, but awesome, beautiful. So thank you for being here. I want to start this talk with a brief history lesson, but it's very incomplete. And this is a brief history lesson of American spaceflight. And credit goes to both these ideas and slides from David Hassan, who's a former NASA engineer that I know back in Austin, Texas. The early stages of American spaceflight were defined by the Mercury program, and specifically they used the Atlas rockets. And what was interesting, this is in the early 1960s, what was interesting about this space program is as they started the Mercury program, they were already thinking about the programs that would come after it and the things that they would need. So they were planning out this stage process of evolving the space program. There were many things they needed to experiment with and figure out. And they knew they couldn't do it all at once, and they couldn't wait. And so there were things in this Atlas program where they literally welded the astronaut into the top of that little red capsule. And they knew that wasn't going to suffice, so they had to figure these things out. And so they progressed from this program, from the Mercury program, into the Gemini program using the Titan rockets, and finally into the more famous of the programs, which is the Apollo program. But back in Mercury, they were things that they knew they were going to need in the Gemini and Apollo missions. So they were already doing early experiments and planning for those things. They had this vision of what they needed to accomplish to put a man on the moon that was laid out in the early 60s. But they knew they couldn't do that all at once. They had to take lots of baby steps. So if we plot this very brief history, we can see they went from these rather primitive rockets, which of course that literally is rocket science, so they're actually pretty complex, but these rather primitive rockets to rockets that were in space and they could actually do manned space missions to putting a person on the moon. And they did not get this way in one giant step, but rather in lots of baby steps. And I think there's a lot to be learned from that process that we can apply to our software lives. And so I want to use that as our theme in the early part of this talk, this idea of baby steps. Many of you know Brendan Eich, the creator of the JavaScript language, and he famously said, always bet on JavaScript. This is an appropriation of the quote, always bet on black, from Wesley Snipes' character in the Passenger 57 movie. But he talks about how every step of the way people have betted against JavaScript, and every step of the way, JavaScript has continued to take these baby steps of evolution and been able to meet the challenge that people were betting against. They were saying it could never do this, and then it did. And they'd say it couldn't be fast enough, and then it did, and so on and so on. And he leaves it as this open-ended thing. Keep betting on JavaScript, because JavaScript keeps winning. And so I want to ask the question, should we keep betting on JavaScript, and what does that mean for JavaScript's future? That's what the talk is today. Now, I'm going to shift into another brief history lesson. This is my history lesson of my journey into JavaScript, really into the web in general, but especially into JavaScript. Like many of you, I've been around the web for quite a while. And some of you are newer, and so you won't even recognize some of these browsers like Netscape and IE, but this was the early days of my entrance into building for the web. This is in the mid-90s when there really was just starting to be an internet thing. And there was IE4 and Netscape 4 and Netscape 6. Actually, Netscape 3 when I was in high school. That was the first web browser I ever used. And like many of you, the way that I figured out how the web worked was to use ViewSource. I went to a web page and I clicked on ViewSource, and this magical document popped up, and it showed me all these magical codes of how to do things. And of course, the one thing that I really wanted to figure out when I clicked on View Page Source was how did they make those little mouse cursors trail around the screen? That's what I wanted to know. Making that mouse cursor move around was state of the art, and I wanted to know how they did it. So I did View Page Source, and I looked at that code. Now, I progressed on from silly things like mouse cursors into more advanced things. Now, this is the earliest of the websites that I ever built that I could pull up. This is from, I think, 1999 or 2000. And this is some really hardcore JavaScript where I was dealing with IE4 and Netscape 6 and dealing with layers. And I particularly love how bad I was at even my coding style. I didn't even realize that I didn't need those extra parentheses around it. I pulled this up from archive.org, the webpage archive. Another of those sites that I built at the same time, and I'm real excited about my usage of eval. That was really great, and I'm very proud about this particular code. So in the early days, I was doing as most people were doing, which is just fiddling around, figuring things out. I didn't really know what I was doing. But I was taking those incremental baby steps, learning more and more about the web and more about how to deal with JavaScript. This progressed into a career in JavaScript development. I took a job at a digital agency and got the opportunity to be the lead developer building out the front page design, the redesign of this website for a regional airline in the United States called Southwest. And I built this in 3 weeks with a team of 3 other developers right before Christmas. We were handed these designs, and this again was back in the 2006 time range, so we didn't really have great browsers, and we'd just gotten the emergence of JavaScript libraries and frameworks that were just starting to come out. And the big hot thing back then was YUI, and so we had this YUI calendar widget that we needed to put on the page, and that's what the design called for, and we figured this stuff out. We figured out how to coordinate all the things and change all of the, where the arrows showed up and all these little intricate things that we had to figure out how to configure in the JavaScript code. And then right before we launched, right before Christmas, they came back to us and said, you also need to support Netscape 4. And we're like, no, there's no way that this YUI calendar widget is going to work in Netscape 4. I moved on from that to working for a brief period of time, about a year or so, working heavily in Flash. And I built websites like this one. This is a kid's website for a grocery store chain. And I built this, and I was definitely cheating because it looked like JavaScript, but it was ActionScript. It was inside of this Flash runtime, and it seemed to be a lot more predictable and that sort of thing. So we could do a lot of fancy things back then. This is even before the days of Canvas was on the web, and so we could really draw with this canvas of Flash in ways that we couldn't do with the web. And Flash is definitely the precursor to a lot of the things that we can do on the web today. Now, I moved on to really focusing on the dollar signs, and of course I don't mean actual money, I mean jQuery. jQuery came out in 2006, 2007. The very first thing I did was open up the source code and figure out, what is this dollar sign? I literally did not know that dollar sign was a valid JavaScript character for a variable name. I was like, how are they doing this magic? So I'm opening up the source code, trying to figure it out. I had no idea. I didn't even understand Clojure at the time, so I was really just fumbling around, but I wanted to understand JavaScript at this deeper level. I didn't just want to do mouse cursors. And so I began to work on some of my own open source projects. And this is actually the first project I ever open sourced, meaning I put it out there on the web. This is pre-GitHub, so this was open sourcing on websites like SourceForge and so forth. This was a Flash-based XHR, AJAX replacement, so that you could do cross-domain AJAX before there was such a thing. And this is some pretty amazing code that I wrote. This is, again, back in 2000, about 2008 or so is where we've advanced. So I'm starting to get a little bit better. I've got better code style. I'm not putting unnecessary parentheses in places. I'm certainly not using eval anymore. And then I moved on to another project, probably one of the ones I'm most known for, which is Lab.js. It's a dynamic script loader. And you'll notice that some of the same themes, the recurring themes of loading things, dealing with things dynamically. And Lab.js is still in place today, still used on many websites, and I'm actually working on a rewrite of that library. So that's, again, about 7 years ago now. So we're into 2008 and 2009 by this point. In about 2010, 2011, I've been speaking on the circuit for a while, and people started to ask me, hey, have you written any books? And I thought, I don't know if JavaScript needs any books, because we've certainly got JavaScript, the definitive guide, and we've got JavaScript, the good parts. And this is that famous, funny picture that's supposed to make fun of JavaScript, because there's supposedly this huge gap between everything you can do in JavaScript and the stuff that's supposedly good in JavaScript. And whenever I saw this picture, what didn't occur to me was to make fun of JavaScript. It occurred to me that it was sort of sad that there's this giant gap between these two, but it's not the gap between the good parts and the bad parts. It's kind of like comparing a set of encyclopedias to Cliff's Notes. Now, if you had a set of encyclopedias, there's no way that you could use those encyclopedias to properly prepare for a test. But also, if all you read was the Cliff's Notes, you certainly can't have claimed to understand that particular novel. There's a huge gap here, and there's something missing in the middle. And so I decided to fix that by writing a series of books called You Don't Know JavaScript. Many people know about those, so there I fixed it for you. In other words, my steps into this have been baby steps as well. I wasn't born knowing JavaScript the way that I do today. I had to take all of these same little steps and all of these same little stumbles. And those baby steps and those incremental progress have been good. Yet again, not another history lesson, but now let's focus on JavaScript, the language. I tried to go back and find examples of code or examples of things that could have been done in code in the earliest days of JavaScript. This is JavaScript early, before it had even been standardized into version 1. But you could do code like this. This is an actual function that was on an actual website in like 1996, and one of the first websites to use any JavaScript on the web. And this is code that you could actually do back then. It's kind of interesting because there's more sophistication there than I would have expected from the earliest days of JavaScript. Once it had been sort of formally standardized into version 1 and 2, you could do even more sophisticated things, like, for example, take advantage of the prototype. Very primitive support here, not the same as what we have today, but certainly the early progression of those features were already landing in the language. The big standardization for JavaScript, the big version 1, if you will, was ES3, actually. And that happened in 1999, and we got things like closure, because we had functions as first-class citizens, so we could return them from another function, and now we could actually use closure, and that was a huge deal. Except at the time, I had no idea. I wouldn't learn about closure until like 5, 8 years later. We had ES4 came around, or was being discussed for a while. It was actually going to take the JavaScript language in a significantly different direction, much more like Java or C++ than it had ever been before. And actually, this ES4 is what happened with ActionScript. So some of my days working in Flash and ActionScript were exactly this kind of code. This is the folks at Adobe, they decided to build out an implementation of ES4 because they were the proponents of it, and they made it into ActionScript 3. Unfortunately, for a whole bunch of political reasons, this completely died. And actually, maybe that was probably a good thing, because they were trying to do a lot of things with the web that really didn't culturally fit with how JavaScript developers approached building for the web. Around the same time, this is often confused with ES4, we had a thing called E4X. E4X was putting these XML snippets directly inside of the JavaScript. And if that looks familiar to you, I think it's an early precursor to the ideas of JSX. Now, E4X was definitely not that. It was definitely trying to not work with HTML, but work with XML as a data structure natively inside of JavaScript. It used this strange sort of XPathy kind of syntax to traverse the XML or whatever. This died a complete and horrible death, and I think for good reason. It didn't belong in the web, and it certainly didn't belong in the web back then. It's often confused. But both of those were this kind of intermediary ground where we tried to get some standards processed, but for political reasons, most of this died. Fast forward another 10 years from ES3, and we finally got ES5 in 2009. And we got some interesting improvements, but they were really kind of small improvements in the whole scheme of things. We got strict mode, which is a hugely important thing. We got getters and setters, which nobody used. We got a few other little things like object.create. But for the most part, what we had was what we already had, just a little bit cleaned up. So it was sort of like a compromise version for the language. Took another 4.5, almost 5 years for us to get to the point where we could land ES6, and that was the huge change set. All of these changes that actually had been building up since ES4 finally landed all at once in this one giant change set. So this was definitely not a baby step, but it was comprised of a bunch of ideas that had been baby steps along the way. And there's far too many ES6 features for me to even list. Now, ES6 is often thought of or often called ES 2015 because technically, very late in the game, the TC39 committee decided to rename it from ES6 to ES 2015. But coming from somebody who had already published a book with ES6 in the title, it's not called ES 2015. Stop calling it that. It's called ES6. Now, after ES6, certainly the year-based naming took over. So in ES 2016, many people called that ES7, and you're also bad for calling it ES7 because it's called ES 2016. That is the official name for the language. I actually still hear people today talking about, hey, when's this thing going to land in ES7? As if ES7 is this general phrase to refer to anything after ES6. So don't call it ES7, call it ES 2016. Very small change set. We got array.includes, and we got the exponentiation operator. That's it. Just two tiny little features. So it's almost like we got small and then giant and then small. It's like we're kind of swinging back and forth. But again, all of these things are comprised of tiny baby steps. Then we had ES 2017, comparatively quite a bit more. One of our favorite features for most of us is async await, finally landed in ES 2017. That's the promise of being able to deal syntactically with promises in a more sane way. And there's a whole bunch of other things that were added as well, but ES 2017 was largely defined by async await. Earlier this year, we got ES 2018. And ES 2018 added several things which are really important, including not only did we have async functions and generators, but now we have async generators. It's kind of filling in the final last piece of the puzzle for dealing with asynchronous programming. So now we have an asynchronous generator that can both yield and await at the same time, and that's super important. We got asynchronous iteration with the 408. We also got some interesting improvements to regular expressions, like named capturing groups and look behind assertions. Those are things that should have come in a long time ago, and we finally have those added as well. So the story of JavaScript has been these little baby steps, and it's made certainly quite a lot of progress. You're probably tired of me talking about baby steps at this point, but there's an important reason why we should be thinking about how, when you're taking baby steps, are you thinking about where you're going to land, where you're going to end up? Most babies aren't. I would say that up to this point, we could certainly feel a theme that the best progress is the progress that's been incremental. And that's definitely been true of a lot of our industry. So, with that in mind, where are we going to be placing our bets as we go into the future? Are we going to be placing our bets in the same way, or should we be thinking about things differently? Should we be shifting our strategy about what we're betting on? So there were some bets earlier in the web that turned out to be really terrible bets, at least for the web as far as that's concerned. These were bets against the openness of the web and more towards the vendor-controlled, sandboxed, containerized versions of the web, these plugin-based ideas. And I'm even going to go so far as to say, even though these are clearly bad ideas, this may be a little controversial, but I'm going to say that app stores were also a really bad idea. Eventually, we're going to say that was not a good idea for the history of the evolution of computing and of mobile computing and so forth. So these were not such great bets. But it turns out there have been a few really good bets that continue to pay off well. For example, the open web technologies like HTML, CSS, and now progressive web apps, bringing those things together and bringing together the features that take web applications and put them on par or even better than JavaScript applications. I'd say progressive web applications have an opportunity to outpace native applications because we already know in the web how to handle accessibility. I know that's not a cool, popular term, but accessibility is already a thing that we know very well how to do. We don't always do it, but we know how to do it so much better in the web than anything I've ever seen from native applications. We have an opportunity to outpace native if we take advantage of what the web can do. These are great bets. Now, the International Space Station that's still flying around up in space was a famous collaboration between two space programs. Others were involved, of course, as well, but the United States and Russia combined their efforts together. They had to figure out how to agree on metric versus the other units of measure and all these other things, and they figured out how to build a space station and put it up in space. I think it's a famous success story for the power of open collaboration. That's why those technologies, like HTML and CSS and JavaScript, that's why they're winning, because they're being built in the open and they're being built through collaboration. And those have always turned out to be good bets. In fact, not just in our industry, but really throughout all of history, the best bets have been on open collaboration. But there is change afoot. There is something happening. There is a fork occurring within the space industry, of course. There's a fork between state-run space programs and privatized space programs. And we're not really sure exactly where that future is going to leave us, but it's definitely going to leave its mark. It's definitely going to be a different sort of story several years from now than it was 10, 15, 20, and 30 years ago. But there's also a fork happening in JavaScript. JavaScript is, and has for a while, been being pulled in two different directions. Being pulled in the direction of what is good for the language and pulled in what is good for the direction of JavaScript to run on machines and to be run by machines and on machines. These are tensions that have been increasing over the last several years. And what I want to talk about for the balance of my time in this talk is I want to talk about what that means and whether our bets are still well placed in this sort of divergent potential future. I want you to imagine if we had two rocket ships here on Earth, and one of them was plotted to one of these galaxies, and one of them was plotted to go to the center of this other galaxy, and we left Earth at exactly the same time. Those two spacecrafts, for a really, really long time, are going to be traveling in what would be completely perceptibly as parallel. They're going to be headed in exactly the same direction. They're going to look like they are cooperating together. But at some point, the closer and closer they get to their destinations, they're not just hundreds or thousands or millions. They're billions and billions of light years apart. And what's happening here is that a path where we're only looking at the baby steps looks like it's not a very divergent path. But if you don't have in mind where is the end goal, you can get way far off. So if JavaScript has been able to take advantage in the early several years here of some divergence that doesn't look too extreme, my question is, will it become more and more so because those different forks have different goals? And that's what I want to talk about. Is incremental, open, baby steps progress that we sort of myopically focus only on what we're doing now, is that always good? Is that still the best bet? So let's first take a look at JavaScript, the language. Let's look at some of the things that are happening with JavaScript, the language, some things that we can observe about it, and we'll compare those to what we can observe about JavaScript that's serving those machine needs. So first off, I'm going to say that all of software development is about human communication. Now, this phrase, code is human communication, I've taken out all the unnecessary spaces, all the unnecessary vowels and things, and you can still figure it out. Your brain is still able to figure it out. But I don't think there's anyone in the crowd who would argue that this is the most effective way to get that message across. This is a far more effective way to get the message across. Sometimes we focus on shorter is better. If I can take out more characters from my code, it's better. But actually, I think that's focusing on the wrong thing, because code is not about the computer. Code is about expressing ideas to other human beings. If you've written an if statement before that did not need an else clause, I want you to just think about that. If you wrote an if statement that didn't need an else clause, in your head you went through all of the ideas, all of the paths of the values that could come in, and you decided that the else clause was not needed. But how much of that mental context did you encode into your program? And the answer is 0. You didn't put any of that in there, you just left the else clause off. Maybe you put a code comment there, but you didn't put all of that thinking into play. And what happens is that code doesn't get revisited until 6 months later when there's a high-profile bug and the boss is really upset, like, what's taking so long? And somebody else, or your future self who's forgotten the code, shows up at that code and says, good grief, why is there no else clause? Maybe that's the source of the bug. And they spend inordinate minutes and hours even potentially trying to reconvince themselves that there's no need for an else clause. Why? Because you didn't communicate the ideas that you had behind the code. It's not just about what you think about the code that needs to be written, but also communicating the code you thought about that didn't need to be written. Code is about communicating our ideas. There's an infinite number of programs that will produce the same sequence of ones and zeros. With an infinite number of choices, and whichever one you pick is just a suggestion anyway, then we should be focusing on how we communicate our ideas to other human beings. This phrase, lingua franca, if you've heard this before but you're not exactly sure what it means, I encourage you to go look it up because it's often used a bit incorrectly. This phrase is often used to just say, oh, like a common language that everybody knows. And it's almost like a negative about something. And JavaScript has been called the lingua franca of the web and even of programming, but I don't think you fully understand and appreciate what that means. Because lingua franca is actually a bridge language between two incompatible languages. It's not some lesser form of communication. It's a higher and more important form of communication that allows two people of different tongues to be able to communicate effectively together. So when we say that JavaScript is the lingua franca of the web, what we mean is it's opening up and widening the tent to bring more people together, people that speak entirely different ways, but they can speak a common way through JavaScript. Now, often JavaScript gets teased and made fun of for being poorly designed. I don't subscribe to that. I think JavaScript is the most important language we've ever invented. And its role as lingua franca cements that. JavaScript is amazing because it truly is multi-paradigm. You don't have to choose procedural programming or object-oriented programming or functional programming. You can mix and match those styles as you see fit. That makes JavaScript more powerful than some languages where you have to choose one or the other. JavaScript is evolving in the direction of being more declarative. That is, a lot of the things in ES6, for example, are things where JavaScript is now able to declare the outcomes that we want instead of distracting the user with all the imperative how-to stuff. So the source code is able to more effectively communicate ideas and not distract the reader from things they shouldn't be paying attention to. These are all very good things that are signs of a good, maturing language. JavaScript also has the idea of backwards compatibility. Now, this could be a little bit debatable because, quite honestly, I wish that we were able to break from the past. But one of the most touted things about JavaScript is that code that I wrote 25 years ago still runs today. It still runs today in today's JavaScript engines. So I'm able to still go back to those really old, crappy websites, and they still run. That's true backwards compatibility. And that's one of the reasons why code survives so much longer and why the web is chosen so much more often as a platform for people to deliver their applications. JavaScript is most definitely not, as you've heard, slow, sloppy, buggy, or inconsistent. All of those things are things you might have been able to say about JavaScript 10, 15, 20 years ago. But the JavaScript of today is far different and fast evolving and maturing to be none of those things. And it's a tired old joke to say, oh, JavaScript, that dumb little poorly designed language. It's a first-class citizen just like any other language ever is, and has the potential, the way it's positioned in the web has the potential to be the most important language that we ever invent. Some things to be potentially aware of, some things that are coming to JavaScript soon, hopefully, maybe. These are proposals that look like they're likely to land. If you're of the persuasion of liking class-oriented programming, there's a bunch of features coming, including class fields and private methods. All these things are going to be augmenting how classes work to fit more of the enterprise sort of approach to software development. So these are all great things. If you're into class coding, you're super excited about JavaScript, not just finished with classes, but it's got a whole lot of things it wants to do. This is a tiny little thing, but I really like the idea that unnecessary things can be removed from the code. We can go back and say, you know, there are unnecessary things that are just cluttering it up. In the early days of JavaScript, they said, even if you don't care about that error binding there on the catch clause, you still got to put it. It's cluttering up the code, and now the catch binding is optional. That just landed in JavaScript. Things like making our numbers more readable by being able to put a separator between the digits in our numbers. Makes our source code more readable. This does absolutely nothing for JavaScript's ability to run the code faster. This is about making the language more readable and more communicative. And that's so important. And things like optional chaining, which are very verbose if you have to keep checking if something is undefined or not. Now we'll have these optional chaining operators to make those things go much quicker. So the truth is that JavaScript, the language, has come a long way from 10 days to now. It's like the early rocket compared to the rovers that are driving around on the surface of Mars right now. But what about JavaScript, the machine? Because it certainly has been coming on over the last 3 to 5 years, is getting more and more attention, and I would say is starting to heighten that divergence, that gap between the two. It used to just be, well, we'd add a couple features in, but now we're going in significantly different directions with JavaScript. One of the reasons for that is there's increased demands. There's a wide constituency for the web, and there's a wide constituency for JavaScript. People want a lot of things out of the language, so it doesn't just evolve based upon someone biased like me who's a teacher that says, hey, let's have a feature that makes it cleaner to express an idea. They also have to respond to the concerns of somebody who's building this hyper-optimized game, and they need some kind of, SIMD extension so they can do parallel math, right? So it's got to pull in these different directions, and I'm not saying that serving those different constituencies is bad. I'm simply saying that only focusing on the tiny baby steps without having the roadmap in mind, it can lead to a destination we may not like. Some examples of things that have been added to JavaScript, which I really don't think are there for anybody to actually write. I'm not really thinking that very many people are ever going to write their own proxies. They're cool, they're interesting, they're magical, but nobody's going to hand author the proxies. This is the stuff of frameworks. This is the stuff of transpilers. Typed arrays and data views, again, unless you're doing some really high-performance math sorts of things, in graphics processing or other things, you're probably not diving into the endianness of the bitwise representations of numbers in your browser. That's probably a little too low level for most of us developers, but this is important stuff because there are very important libraries and frameworks that are making use of these kinds of things to squeeze out every last ounce of performance. This one sort of hit me out of nowhere. I didn't even have this on my radar screen. Early last year, we landed shared memory. literally support for being able to run JavaScript multi-threaded. The ability to have 2 threads of JavaScript share a memory segment. That just landed like poof out of thin air. And then we started realizing, well, that can be a problem because we don't have any primitives in the language for how to deal with threaded concurrency. So we better fix stuff like just checking with an empty while loop. That's not going to cut it. And so we added atomics. Very low-level things, which I'm sure nobody's ever going to write their own atomics code, but there's going to be frameworks built on top of this that allow us to manage concurrency across threads in JavaScript. I stood on a stage like 3 or 4 years ago and very stupidly said, JavaScript's never going to have threads. And then I ensured that it happened, right? It landed in the language because there's a desire to make threaded programming in JavaScript work. Most of us know that the code that we ship is not even the code that we write anymore. There are so many separations between the code that you type into your code editor and what actually runs in the browser. And an example of that, there are many, there's Webpack and others, but an example of that is the Babel transpiler. Babel takes this nice, beautiful code that we write and turns it into this amazing code here on the right. Now, that's necessary, obviously, because we want to bridge the gap between what the language can do now and what the browsers we're supporting could do 5 and 10 years ago. I certainly understand the need for it, but I don't think we really step back and realize the barriers to entry that this is creating. Not only the tooling barriers to entry, but just from the perspective of the code that's running on the web is so vastly different from the code that the developer wrote, that the question that comes up for me is, how is a developer supposed to do that whole view source thing anymore? How are they supposed to onboard to the web when we've created so many layers of abstraction in the advancing of all this great technology, which is awesome and I've been super excited about? Did we lose sight of the fact that the way people got onto the web was view source? Now, you're going to say, well, we've already got that solved. We've got source maps. Source maps are how you go from your initial code that you wrote to the code that's running inside of the system, inside of the browser. Yeah, sort of. There's some problems with source maps. Namely, stack traces and watch expressions. They don't really handle like vastly different languages. They don't handle the case where you wrote 2 lines of JavaScript and then it's actually running 5,000 lines of transpiled JavaScript. That doesn't really work quite the same way. And then the question is, what if there's multiple steps of transpilation? What if you have a JSX compiler and then you have React and Babel and then you have Uglify and you have all these different steps? And what if there's a problem right in the middle? In between them. Multi-stage source maps are an idea, but they're not actually a thing that really works out in the wild. So the question becomes, will somebody be able to come to the web 3, 5, 10 years from now and have any idea how it's going? They're not going to want to make mouse cursors anymore, but they're going to want to understand how you build all those widgets. And are they going to have any hope of doing so? TypeScript is a fantastic tool. I don't use it personally, but I get asked about it a lot. I think it's a fantastic tool, especially if you work in an environment that requires you to go between statically typed. You don't want to switch your brain into the dynamically typed world. I totally get that. TypeScript is fantastic. I love their interfaces feature. That's a really cool feature to create this idea of what a data structure should happen, and you can switch out the implementation under the covers. Interfaces are fantastic. So TypeScript is another one of those tools where the code that you write is not at all the code that's shipping to the browser, and it's creating more and more of these barriers. These are all demands that we're putting onto the language that are not about how JavaScript the language can be better read, and more about how JavaScript the language can be better compiled to. Another example, if you've followed much about Sweet.js, this was a thing a few years back. I'm kind of hoping that maybe this still happens, but we're talking about adding macros to the language. And this is a library that adds them on top, but it would ideally be just the feature is in the language. Other languages have had macros for a long time, so we're talking about adding macros to the language. Macros are yet another layer of abstraction between what was written and what's actually going to run in the browser. And I'm wondering what's the developer tools going to deal with when it didn't even get a chance to see the code, and there's no source map in between. This was just on-the-fly code that was rewritten inside of itself. This is an example of a macro that takes a let declaration, which is the silliest of things, but it takes a let declaration, transpiles it into this thing, basically. Not really transpiles it, but that's effectively the code that's going to run in the browser. So what's that going to mean when we are transforming our code on the fly inside of the browser? Tom Dale, many of you know Tom Dale. He's been around a long time in JavaScript, done a lot of things, famous for being one of the core devs on Ember. He wrote an article last fall about compilers and all these transpilers and compilers that we're using. And he basically said, this is the future of JavaScript. We're not going to be like using frameworks anymore. He said 5 years from now, we're going to just be compiling every piece of our code. So the framework won't even be a thing that you load into the browser. The framework will be a tool that transforms the code that you wrote on the server and ships out something entirely different than what you wrote. And you can see why that's creating more. In the advancing of our technology, it's creating more and more of a gap, more and more of a separation between these two JavaScripts. Now, I got interested in, well, maybe I could experiment with building my own sorts of syntax extensions and building compilers. And so I came up with an idea. I'm kind of into functional programming. I came up with the idea of defining this syntax where you could put the 2 parentheses on a function declaration to define a curried function declaration. Instead of having to use a tool to do currying, you could just define it directly in the syntax. Got some early feedback from people. People said, oh, that's cool, that would be interesting. So I thought, hey, you know what I'll do is I'll build a little extension on top of Babel just so we can play with this and see how it works. So I started talking about that, and I immediately got shot down by a few TC39 members. Not because they didn't like the idea, but they said, absolutely, positively, do not go make your own compiler. Don't make your own extensions. We don't need experimentation because we don't need developers fragmenting on what they figure out and what they start shipping. If enough developers liked your compiler and started writing that code, now you've made that a dependency, even if we don't want to put it in the language. So they were very concerned with this idea of experimentation. Apparently, you can only experiment if you happen to be on the committee. I don't know. Now, ASM.js, you probably know about this, it's been around a long time, but it was the idea of subsetting JavaScript. This is not code that you would write, but certainly the famous success story was that we were able to take 1.5 million lines of highly optimized C code and in a couple of days transpile that into JavaScript and run the Unreal game engine at 60 frames a second in the browser, taking advantage of shortcutting a lot of JavaScript slowness with its type coercions and garbage collection and things. So ASM was the early precursor to WebAssembly. Now, WebAssembly is a fantastic technology advancement. I'm absolutely excited about opening up the tent to more and more people wanting to write code for the web. If you're not familiar with what WebAssembly is, essentially, you can take some language like, say, Go or Rust and compile it into a representation of code that the JavaScript engine, not the parser, but the engine itself can understand. It looks kind of like this. And the real important thing is that you can express things in this code that you cannot express in JavaScript, the language. So that relieves some of the stress to change the language to suit some of the needs, for example, threading and things like that. But also the big win is that this code is supposedly a lot faster for it to process in the browser. So you do most of the work ahead of time in a compilation step, and it reduces the parsing time to almost nothing. Ironically, WebAssembly will probably be targeted by almost every language in existence except for plain old regular JavaScript, because the way that it works is based on types. So if you're using TypeScript, great, you'll probably be able to target WebAssembly, but if you like to use regular plain old JavaScript, old school like that, you probably won't ever be able to target WebAssembly. And again, I ask the question, what does this mean for our future of view source? When somebody shows up on a website, there's not just one or two technologies like JavaScript, HTML, and CSS. There's JavaScript and Go and Rust and 5 other languages involved in what makes that web page work. And so now a new learner doesn't just have the barrier to go learn 1 or 2 languages, but they have to learn a dozen or more different languages and technologies to figure out what a website is doing. Even if we have source maps, it's not going to be particularly easy for someone that's beginning to learn and onboard onto the web. So as I finish up, just this question that I want us to ask. This talk was going to be called, before I called it Keep Betting on JavaScript, this talk was going to be called A Tale of Two JavaScripts. For a long time, it's been okay for us to just allow these two to intermingle together. But they are diverging. And for a while, this has been a good bet. But my question is, going forward, are we going to be betting on this dual direction of the language? Is that going to be healthy for us? Are the same bets on JavaScript that we made 10 and 15 years ago that were great bets, are they still going to continue to be great bets when we're betting on two entirely divergent sets of goals? I'm not so sure. So I want us to have better, more responsible conversations about it, because ultimately I think what we need is to be placing our bets that humans are going to keep dealing with JavaScript. We're going to keep writing code, and we're going to keep communicating our ideas. Thanks very much for your time. I appreciate you all being here, listening to these thoughts.